Okay, here we're going to look at the Eico 667 tube tester that I have. I have gone through it at this point. I've replaced out of tolerance resistors and electrolytic capacitors and so on. Somebody asked if I would demonstrate it testing a 12AX7 and a 6V6. I also will show some 7591s as well, as they're not in the roll chart, and explain a little bit about that, and also the transistor test function that it has. In fact, I'll start with the transistor test function. First, I have a 2N3724, and we'll test that. First off, before we even do that, I have to turn it on and calibrate the line so it's centered on the meter. And my line voltage is apparently very high right now because I did calibrate this fairly recently. And this is an NPN transistor. We know it's an NPN transistor. So you need to know the pinout and the polarity before you use this transistor tester. And position 1 tests for leakage, just leaves the base open, and position 2, the current gain check. And it shows up right around 90, and that's what I tested with this transistor from a different kind of test setup I did with just a plug-in breadboard and putting a known current on it, and measuring the base current. This does it backwards from the way data sheets specify transistor current gain, where it puts a fixed base current and measures the collector current. It's good for no-go testing, and as you'll see, many modern types have much more current gain than 140, and they will just pin the meter. I have set it up so that it won't damage the meter if it pins the meter. Here's a modern high gain selection, PN2222A. No leakage, and of course it pins the meter. The other thing I had to do was, no matter what I did with the original way it was designed, the current gain was never accurate, so I ended up changing a 10 microfarad cap they had in there to 22, and that gave the right average voltage with ripple to make the meter read pretty close to accurate for most transistors, assuming they have flat current gain. Anyways, on to the tubes. First of all, select the tube from the roll chart, and the roll chart is known to be wrong on these, so you'll have to use the instruction manual. Tells you how to develop tests. You can download a PDF manual from this online. I've just Googled Eico 667 and found one somewhere and downloaded it, or somebody had scanned it. With the 12AX7, it checks 1/2 of it at a time, and the first test tests the first half. So we these switches, this corresponds to a pin on the socket. Obviously, if it's higher than the pin on the socket, it doesn't go there. C refers to the plate cap. This could be a shock hazard if you put this on the plate. 1 is ground, 2 is filament, 3 is usually for screen or lower plate voltage, 4 is plate, 5 is grid, and 6 is open. 6 is for when elements are not used, or perhaps the cathode shares another pin, you can just put it on 6. V is the plate voltage, which range it's on, and as well as screen voltage, or the position 3 voltage here. They both are relative to each other. S is the sensitivity of the meter. This is low sensitivity. This is high sensitivity. This puts resistance in series with the meter. This puts more resistance in series with the meter and less resistance in series with the meter to change its fine sensitivity. And the grid, of course, that's self-explanatory. That also changes the amount of grid voltage. First of all, always start with the filament at 0. You don't want to burn out filament in an expensive rare tube. And for the 12AX7, to test the first half, we start with, make sure that everything is in the right position. So we'll start with 4 on number 1, which puts pin 1 of the 12AX7 as anode A, or plate A. And then we will want this to be on the grid, so it's 5. And then we want the cathode to be grounded, so that's 1. And then 4 and 5 are the filament, so we will put, leave it on 1, 2, that puts it on, actually gives it filament voltage. The other side of the filament is connected to the common ground in this unit. And then pin 6, 7, 8, and 9, we'll just leave up, because they're not going to be connected to anything. This section, this is the center tap of the filament of the 12AX7 pin 9. In fact, I'll demonstrate this before I'm done with the 12AX7. And we want to start the leakage pin, which is pin 3. It's the underlined pin. It's already depressed. So we'll plug in our 12AX7. And we put this on 12.6 volts. Another thing to do is make sure the line doesn't change the filament current. We'll change it a little bit. And we are good. And so let's do our short tests. So we press 1, 2, and then we want to do merit on 1 and make sure that the 2 is not stuck. So let's reset. The switch is stuck here. There we go. 1. And we also want to make sure that our grid and plate are in the appropriate position. We've got V, 2, S, 4, and then we want the plate control on 80, and the grid control on 15. And of course that half gives a question mark. This could potentially work though in a lot of applications. Of course you won't know if it's noisy, and you won't know if it does have enough gain to start an oscillator, if it's in an oscillator circuit, etc. But there's a lot of places where this tube would still work. Alright, and then we can pull the tube out, reset the positions for the other half. And for our roll chart, we know that these will stay the same, we know that these will stay the same, and we know that the filament will stay the same. And we know that pin 1 is the our position 1 here is not where this needs to be. This needs to be on 4, 5, and 1. And then we will put the filament center tap, where it's disconnected as well. This puts plate, grid, and cathode to an open circuit. And plug the tube back in. Oh, first of all, I almost forgot something. I want to make sure that we're in the right position for testing for shorts first. So let that warm up. Okay, we're good there. And then we want to do our other leakage tests, are 6, 7, and we're good. And merit will be on 6. And that section of the tube checks good. But one thing about the 12AX7 is it does have a filament center tap, which is pin 8. So we could, in theory, take 4 and 5, ground, and then put, or pin 9 is the filament center tap. I think I said 8. So we can take pin 9 and go to 2 here, and first let's fill it down to 6.3, and plug in the 12AX7, 8 for leakage here, and both halves of the tube are lit. I'm not showing it on the camera very well. And this works too. So we can do this and check the tube that way. Alright, and that does it for the 12AX7. Next, let's look at a 6v6. This one says Lowry Organs. It's got the octagon logo. It's really an RCA. And it doesn't look like it has a lot of hours on it. Alright, now this is 6v6 in the roll chart. Going the wrong way. Going the wrong way on the roll chart. I am definitely not on a roll. Six v6, and it says 20, 60, and 6, 1, 4, 3, 5, 6, 2 are the positions. 6, 1, 4, 3, 5, 6, 2. And leaves pin 8, number 1. Alright, now the 6v6, of course, is a 6.3 volt filament. We're on 6.3. And we will want to start with number 8 for leakage. Okay, no heater cathode leak. And we want to check for shorts, so we will do 3, 4, and 5. No plate shorted, no screen shorted, and no grid shorted, grid number 1 shorted. Alright, and then so merit will be 3. And of course we forgot to do something. We want higher plate voltage and a sensitivity to be on 2. And we have a question mark. Just barely. Now I can explain a couple of things here. This is the plate voltage. Lower, higher. This is the meter sensitivity. Lower and more sensitive. So if we're here, this might pin the meter. And obviously you don't want to damage the tester, so don't do that too much. Lower voltage, lower voltage. So you can develop your own tests using the manual that you can find online. That's what I brought up earlier. And as the tube heats up, it's got a little better, I think. Something else, if it draws a lot of filament current, you may want to check the line, adjust. And it has drifted down a little bit. Not to mention the line may fluctuate quite a bit. So we can do that. Now it says it's good. Now, of course, you can develop tests for tubes that aren't in the chart. And what I'm going to do is I'm going to start with these settings and use a 7591 in here. Normally, always start with the filament at 0, just to be on the safe side so you don't burn anything out. And here we have a Toshiba 7591 that's quite used. It looks like it may have even run away or something in whatever it was in. Looks like it's been really hot. It has a different pinout than the 6V6. It is a similar tube. I'd have to look at the actual data sheet to figure out where to position some of these controls relative to a good normal 6V6. Filament is the same, pins 2 and 7, but pin 8 is also connected to the screen. And I believe everything else is pretty similar. We can look up this book here, and we can look up the 7591's pinout in here. It's floating around in here somewhere. Probably I'll actually look it up instead of playing a guessing game with it. This will be an 8. Okay, Q. So 3 is the anode or plate. Pins 2 and 7 are the filament. Pin 4 and 8 are the screen. Pin 5, however, is the cathode. So that's a bit different. So we want pin 5 on 1. We want pin 6 is grid number 1, put that on 5. 1 is unused, so they can stay open. Now, put in our quite used 7591, and we will use pin 5 here. So position 5 is our leakage test. Okay, so right there, no heater cathode leak. I'm going to check for shorts otherwise. We got 3, 4, and 6, which is plate, grid number 2 or screen, and grid number 1. And there's no shorts, and then merit should be 3. So merit, and of course it says replace. But again, I'm not sure that these plate and grid settings are entirely correct for this tube, but I'm sure it's pretty worn out. Now if we wanted to change this, we can either increase the meter sensitivity. We could also put more current onto the screen by putting the anode and screen on the same voltage. We can also increase the grid drive. Or we could also increase the meter sensitivity. So there's a bunch of different ways to accomplish getting settings for different tubes with this. You'll just have to look at the manual and figure out what you need. This is not something for somebody that's not technically inclined. Alright, and I have some more 7591s we can look at too. I have there's an old RCA 7591. And what's it here? Start with our leakage tests and short tests first. Alright, and see that one shows us good. So this old Toshiba tube is clearly quite worn out. And I have another one of these as well. And we'll go back to there's another old Toshiba one. And this thing has gotten very hot. There, 3, anode, grid 2, grid 1, no shorts, back 2, and another plate, and it says replace. And we can also, one thing you can do is we can see how much current the screen is drawing when we do this. You can see the screen is drawing some current. So if we change the meter sensitivity, we can even see the screen draw current. So this is another test you can make up from instructions that are for this tester. Okay, well that's it for the Eico 667 tube and transistor tester. And almost for my tubes.